So last time I showed you guys this A-level inequality, but many of you guys told me this is not the A-level way to do it. Well, I don't have much experience with A-level syllabus, but it's okay, because today I will have Jaymin from JPy Math.
Hi, my name's Jaymin. Welcome to JPy Math.
He is going to do it for us. Jaymin graduated from University of Oxford with a degree in mathematics. He has tons of experience helping students do better on the A-level test. He also has a YouTube channel, JPy Math, with tons of interesting videos that you should go check it out. But right now, let's go ahead and welcome Jaymin because he is going to show us the A-level way of solving this inequality.
Thank you so much for having me on the channel. So A-level teaches you to solve this type of inequality by first making it into a polynomial of sorts, sketching that polynomial and using your graph to help you determine the solution to this inequality. So I'm going to be following that method here. Now, the first time you see this, you might think, okay, cool, let's just multiply both sides by x and get x squared, x minus 1 is bigger than x minus 1. However, you cannot do that. The reason why we can't do that is because if you multiply both sides by x, yes, this becomes x squared, x minus 1, and yes, this becomes x minus 1. The issue is actually in the middle with the sign, because potentially the sign could flip around. If x is a negative number, this bigger than sign, when we multiply by both sides by a negative number, would turn into a less than sign. You flip the sign when you multiply or divide by a negative number. And the issue here is we don't know whether x is positive or negative. In fact, that's what we're kind of trying to work out. So this doesn't quite work. So we have to go back to the drawing board here. What A-level teaches you to do is instead of multiplying both sides by x, multiply both sides by something which we can guarantee is positive. So in this case, we can guarantee that x squared is positive. So we're only looking for real numbers x. So multiplying by x squared insists that this guy here on both sides will be positive. Now, you may ask, well, what happens if x is 0? Well, we don't have to worry about that, thankfully, because on this side here would not exist if x is 0. So we know we can essentially assume x is non-zero. So we multiply both sides by x squared. And the great thing about this is positive. It won't change the sign. So this will become x cubed times x minus 1 is bigger than, and then this right-hand side here, one of the x's will cancel out, and you're left with x times x minus 1. So x cubed times x minus 1 is bigger than x minus 1. Cool. Let's shove everything onto one side and make it bigger than 0. So I'll bring this onto this side, and we get x cubed x minus 1 minus x minus 1 is bigger than 0. Okie dokie, cool. So now what A-level teaches us is we are going to try and sketch this guy here. So we're going to try and sketch the graph y equals x cubed x minus 1 minus x minus 1. Now, before we go and expand everything, what we're actually going to do is factorize this, because we can see there's quite a few common factors between both these two terms. X is a common factor, and x minus 1 is also a common factor. So we can take both of those out, like so. And this first factor here, we're just left with x squared, and this guy here is just 1. So get y equals x times x minus 1 times x squared minus 1, and then we can just use the difference of two squares, because this thing here is just x plus 1, x minus 1. So if I bring this up here, we have y is x times x minus 1 squared, because we've got this x minus 1 and this x minus 1, and then we've got this x plus 1 here. Cool. So we've got what y is as a function of x, and as I say, we're going to sketch this graph. So let's roughly sketch this. So we can see where are the roots of this? Well, it's at 0, 1, and minus 1. So let's mark those on. 0 is there, 1 is roughly there, minus 1 is there. And I see that this is a quartic function, so I know, and it's a positive quartic, so it's going to have roughly some sort of W shape-ish. Okay, I also noticed that this guy here is a double root. So it has a double root when x is 1, which means it just touches and then will carry on. So it's going to look something like this. It'll go through minus 1, come back up through 0, come up like this, and then just touch at 1, and then go up like that. And I get my W shape, and this is the sketch of this graph. Okay, cool. How do we use this to help us solve this inequality here? Well, remember, we're trying to solve this inequality here, but this left-hand side is just y. So we're just trying to solve the inequality y is positive. And well, we can look at our graph here. When is y positive? Well, the x-axis here is the line y equals 0. So anything above the x-axis will be where y is positive. So I look on my graph here and I see which sections of my graph are positive. Well, I've got this guy, and this guy. They're all positive. So I just need to describe the x values that determine these three kind of segments. Well, this first one here, that's clearly when x is to the left of -1. So x is going to be less than -1. Okay, cool. How about here? Well, that's just x is between 0 and 1. And how about this guy here? That's x is bigger than 1. Like so. And that there solves our inequality. We have the three regions for which x satisfies this initial inequality. Thanks so much, Black Pen Red Pen, for having me on the channel. If you enjoy the way I've explained things, go and check out my channel, JPyMaths, link in the description below. Bye.